Okay, we are gonna be looking at Newton's laws. This is a grade 11 chapter which you have to know in grade 12. Majority of the books that I've had, the grade 12 physics books, they don't have it that much. So you're supposed to know it from grade 12. So Newton's laws, we're gonna be looking particularly at the second law of motion, which is the one that most of the time carries more marks. The one that is defined by this equation, the sum of all forces acting on a body equals to the mass multiplied by the acceleration. So if you have a block of a certain mass m, and then it's on a rough surface, and then there's an applied force that is pushing the block. So we are saying that the sum of the forces that are acting on this block are equal to the mass multiplied by the acceleration of the body of the block. So the main thing in understanding the second law is being able to draw a free body diagram. In our case, the free body diagram is going to be like this, because all arrows should point away from the dot. So we're gonna draw the applied force going this side. It's an applied force, and we have normal force. The applied force was given as you can see in the picture. The normal force is a force which acts perpendicular to the surface or to the block. And then we have the gravitational force, which is a force that always acts straight downwards. Sometimes it won't be perpendicular to our block, just like in this case, but then it acts straight downwards. And then we have frictional force. We have friction because in this case we said that the surface was rough. So if it happens that they give you this instead, they say you have an applied force, but then here they say it is smooth. It's a smooth surface. So your free body diagram will still have a normal force, because the normal force always acts perpendicular to a surface, because we have a surface in our case. And then you'll still have a gravity which always acts downwards, and then you'll have an applied force. But then in this case you won't have friction because your surface is smooth. Okay, so let's look at an example to this problem. Let me just assign random numbers to this. Let's say the mass is 3 kg and the applied force is 10 newtons, and they give you the coefficient of kinetic friction, which is 0.2. So when you're calculating, you're gonna say the sum of all forces is equals to ma. You have to understand how your system goes about. If you look at this block, there's no way that it's gonna have, let me draw a Cartesian here, x and y. There's no way that it's gonna have there's gonna be a movement in the y direction. It's a horizontal motion. As you can see, it's on the horizontal motion. So you are gonna consider this too. You're only gonna consider forces or force components that are acting in the x axis. So if you had a force at an angle here, you're gonna resolve it into an x component of the force, and then we use it. So in our case, we're gonna say the applied force minus, we are taking right as positive, minus friction is equals to ma. If you look at what we are given the kinetic of the coefficient of friction mu k. So we know that our formula says frictional force is the coefficient of friction, kinetic or static, multiplied by the normal force. And our normal force is given by mass multiplied by gravity, which therefore means that our friction is mu k mass multiplied by gravity. So in this case, we're just gonna substitute it's 10 minus, substitution straight from the formula, mu k is 0.2 multiplied by our mass is 3 multiplied by gravity is 9.8. It's equals to 3 multiplied by a. A is our known, we are calculating for acceleration. So acceleration, this implies that acceleration is a certain number that you calculated from here.